Good morning, everyone. So we are going to get started today with module M04. So we have reached a certain milestone again in the class, okay, in the course. So module M1, M0, M1, M2, M3, pretty much a self-contained introduction to programming. So the good news is that as of right now, you know already how to program. But the trick is that we use a very somewhat limited subset of the Java programming language. So what's the menu for the remaining modules this semester? So modules M4, M5, M6, M7, M8, and M9. Generally, this is how much time we have in the semester to cover. They are going to introduce more techniques, more tools, more syntactical aspects, okay? So as far as the big idea of how do I break down requirements to solve an algorithmic problem, that's covered. We are going to just reuse what we learned so far and reapply it constantly between now and the end of the semester. But we are going to learn to use new tricks pretty much from the Java programming language to allow us to also gain a better understanding of how things work under the hood, but mostly, get new tools that we add to our toolkit. So main advice that I have to share with everyone at this point in the course is we just went through a few weeks of trying to learn to program a certain way. This idea of building blocks, this idea of trying to extract micro features from requirements that match a building block or a piece of program that we've seen previously as an example. I really recommend that you give this approach a shot. If you already know how to program, then no problem, okay? But if you find yourself unable to actually solve some programming problems, and yet you are not giving a shot to this approach, please give it a shot, okay? It has been designed specifically to help anybody who feels a little lost at the beginning when they learn to program for the first time, okay? So it's a reminder, but very, very important for the rest of the course. So with this being said, let's jump into module 4. So module 4 is going to be about data types. So far we have been playing with only int, double, and boolean as data types for the Java language. We have been playing a little bit with strings, but really we didn't talk much about the string data type. We are going to talk in module 4 about variables. We've been using variables already, so there is very little that I have to add here. And then we're going to talk about I/O operation. We have been using scanner to read stuff from the keyboard. We have been using system.out println to display stuff on the console, or system.out print, okay? Well, we are going to see what we can add to those techniques. So mostly little remarks on edge cases and new syntax. The detailed menu for the module. So we're going to talk about numerical data types in Java. So as we cover the numerical data types in more details, we're going to define them, and we're going to cover also the I/O operation that go with them. So mostly how to use a scanner, for example, to read different types of floating point number or different types of integer. Then we're going to talk about evaluating expressions. So we have been using that term expression since the beginning. Everybody knows what an arithmetic expression is. I mentioned Boolean expression. We are going to cover those in much more detail in one of the upcoming modules, but we are going to also talk a little bit more about the assignment, which is actually an expression, but it's also a statement. So we'll talk more about that. Data type casting, this is going to be the big topic for this module. Okay, this is new. This is how to convert a value from one data type to the other. Do you remember the example that we took when I told you in programming, it's not just about values, it's about values and their data type. So when I said, for example, we have a value of 5, well, if you write down in a Java program 5 just as a digit 5, that's going to be considered an integer. More specifically, an int data type, okay? So it's going to be a numerical, literal because we put the value directly in the program, of data type int. But if you write 5.0, then it's going to be considered a floating point number. More specifically, in Java, it's going to be a floating point literal of data type double. Okay, so now what happens if I want to, for example, to convert 5 into 5.0 or 5.0 back into 5, right? So these are literals. But what about if I have variables that have different data type and somehow I want to assign the value of one variable to another? So this is a topic of data type casting or data type conversion. You can use both terminologies. And then depending on the time and the need, we are going to talk a little bit about number systems. So this is a topic that is also covered in discrete math, okay? We do not need to go super in depth, but I still need you to have like a basic understanding of at least, what is the traditional, base 10 number system, what is the hexadecimal number system, and maybe the octal number system. So these are like the most commonly used, okay, in programming. So we're going to talk a little bit about those. That will be a review if you already took discrete mathematics. And then we are going to finish this module with common errors and pitfalls, kind of make a summary of the most important things that have been biting students in previous semester. So that's for the content of the module. As far as learning activities, we are going to have practice exercise. So the deal is always the same. I introduce them in the slides as they become relevant. So as soon as we cover a topic and there are a few exercises that we can do for practice, there you go. I inject them right there in the slides. So these are non-graded. Again, work with other classmates, etc. Ask for help as much as you need. PQ, practice quiz, non-graded, same thing. Ask for help, work with classmates. And then we have some graded activities. So cooperative GQ, this is going to be released this week. Then regular GQ, that's going to be based on the reading assignment and on the PQ. And then an IE that is going to be, in our case, IE04. Okay, so by now you should be kind of used to what each of those activities entail and what they mean. But if you have any question, or as usual, feel free to ask. Reading assignments. So with module 4, we are branching back into the textbook. So we have been using the textbook at the very beginning, just the first chapter, just as a gentle introduction to computers, internet, etc. Then we went from module 1 to 3, we went a little off rail compared to the textbook. We did our little self-contained introduction to programming, and now we are going to revisit the textbook. So the advantage of this is that as we look at chapter 2, for example, for this module, okay, this is a assigned reading assignment along with a few of the appendix. So when you look at chapter 2, what you're going to discover is that the textbook is going to talk to you as if you are discovering what a variable is, as if you are discovering what a data type is. Okay, so even though we already have a little bit of practice with all those concepts, the textbook is going to review them. In the lecture, I'm going to go fast over those because we already covered the concept. But if you are still a little shaky on some of the concept, then you will find the reading assignment to be a good opportunity to go a little bit over the essential that you might have missed and make sure that you pick those up as you go. Okay, so the reading assignments are not optional. They don't cover necessarily exactly the same thing as the lecture. So here's a list, for example, of the learning objective for the module, straight from the textbook. What you have highlighted in red is what I'm going to more specifically talk about during the lecture. And then what's in black, well, two types of things are in black. Things that we already covered in module 1, 2, and 3. So those are not going to be like the main focus of the lecture. Sometimes I will have a slide with a stamp on it that says déjà vu or something like that. That means I'm just giving you a quick reminder, right? But there are also things, for example, this system.currentTimeMillis method, which is a new method we haven't covered. This is kind of a more of a detailed thing, how to use a new method. So this I'm going to leave it for the reading assignment as well. So just make sure you understand that the lecture doesn't replace the reading assignment doesn't replace the lecture. They are meant to complement one another. Since we're going to rely more on the reading assignment, let me go over a few study tips that I've been giving in previous semester. Some of these have been useful to some of the students, so let's go. Here's a little bit of advice on time management, okay? Because one of the difficulty that some students experience sometimes in a college class, especially the early college classes, is they don't manage properly their time, they don't assign enough time, or maybe they don't assign enough time to specific activities. So I'm going to try to give you an idea of how much time you should be spending on each of those modules. So let's say that our module is 1 week, okay? So we are going to spend already 2 hours and a half in lectures. So that's a given, okay? You attend the lecture or you watch a video. If you watch a video recording at twice the speed, well, that's going to be 1 hour and a quarter only instead of 2 hours and a half. That's up to you, okay? If you can do that, okay? Then what I suggest is you spend about 3 hours after you're done with the lecture. You spend about 3 hours dealing with a reading assignment. So that just doesn't mean like reading fast for it. That means, reading through it, asking questions, trying to play with the examples and stuff like that. So really, this is where you revisit the lecture topics and you go a little bit more in depth, okay? And to help you do that, the PQ. And then when you're done, when you think that you're ready with the reading assignment, that you understood everything there was to understand there, then the GQ is going to allow you to get an evaluation of how well you actually understood the stuff, okay? A new thing that's going to appear in some of our modules, something called live coding videos. So in the past, a lot of students told me that they like when we do live coding in class. So I like it too. It's actually useful. I think we all agree that this is a good thing. Sometimes we don't have time to do as much live coding as I would like to, and as some students would like to as well, simply because we have a lot of concept to discuss, stuff like that, okay? So to kind of give you some extra live coding if you need it, okay? I have those pre-recorded video. It's called the methodology behind those videos is called apprenticeship, cognitive apprenticeship. That means that pretty much if you are somebody who learns a lot by just watching somebody do exercises, well, these are going to be videos that you want to check out, okay? So in those videos, I take an exercise from the textbook and I break down how we are going to approach it, in Java. I go a little bit faster than the method that we studied in module 1, 2, and 3. So this is really just in case you need a little bit extra example on how to do things, okay? But if you watch those videos and you think that they go too fast, then remember you are expected to go a little slower, at least, for the next few modules. Then graded exercise, practice exercise, okay? So spend as much time as possible. You learn programming by programming, so definitely this is going to be the time sink, okay? Depending on a lot of things, depending on the topic of the module, depending on how comfortable you are already with the previous module, stuff like that, you're going to spend more or less time, but this is really where you need to invest a lot if you feel a little lost in this class, okay? And then, of course, there's going to be an IE. The IEs are going to get a little longer as we progress, so they're going to reach a size of about 2 hours very soon. And this is to prepare you for the final, because the final exam will be as well 2 hours. So now that we are done discussing all of this, let's jump into module 4, which is going to be about manipulating data. So let's talk first about numerical data in Java. So we used a few data types. We learned to declare and initialize variables. So let's see what we can add to what we already covered. So int x, little comment to tell me what the variable x is about. Double radius, we've seen those, okay? We've seen int data type, double data type, and also the Boolean data type. The syntax to declare actually in Java is you specify a data type followed by an identifier. So the name of a variable is called an identifier, okay? And then a semicolon. Or you can specify the data type, like int x, an identifier x, and then the equal sign, a single equal, and then an expression that is going to evaluate into a value of the same data type that you specified here, and you're going to assign that value to the variable, so you're going to use the value to initialize the variable. So we've seen that syntax already, okay? And for assigning a new value to a variable, which was the next building blocks, the syntax is always the identifier, the name of the variable, equal, a single equal again, and an expression that gives the value of the right data type. And I already emphasized that, yes, if you have an int variable, you should assign to it an int value, okay? But I also mentioned at some point during module 1, 2, and 3 that, for example, if you have an int variable, you can store inside of it, well, an int value. But if you have a double variable, which is a floating point number, well, you can assign to it, obviously, floating point numbers, but you can also assign to it integer. So I already kind of introduced the idea that in Java, sometime value can be upgraded. So for example, if you have an expression that gives you the value 100, so 100, with that decimal, that's definitely an int value. You try to assign that to a variable of data type int, no problem. You try to assign that to a variable of data type double, no problem. The 100 is going to be converted automatically into 100.0 as a double data type and stored in the variable. The way it doesn't work is the other way around. So for example, if an expression gives you a result of 23.5, you are trying to assign that to a double variable, no problem. The arithmetic expression gives you a result that is a floating point number, so a double. You assign to a double variable, you're okay. If you try to assign this to an int variable, then you run into trouble, okay? The compiler is going to tell you, I cannot fit a double precision floating point number inside an integer, okay? So, an int variable, sorry. So, int is kind of a smaller data type than double. So, you can store ints in doubles, but not double in ints. So that's pretty much everything that we covered regarding numerical data type until now. And what I'm going to throw into the mix on this slide is a new data type called char, character, okay? So this has no, I should not say this has nothing to do. This is not the same thing as a string, okay? A string of text that we represented in our program by writing double quote followed by whatever our text was and ended by double quote. So a string of text is meant to have a bunch of characters inside of it. It could have 0 character, in which case this is an empty string, or 1 character, or 2, or 3, or 4, or a million, okay? A char is different. A char variable means that this variable is going to only contain a single character. Here's an example. We declare a char A and we don't initialize it here, so always not initializing variable in this course, always a bad idea. So let's look at those. Those are better. So I declare a char named key, and I initialize it to Q, the letter Q, 1 character, okay? So to tell Java that this literal here is not a string of text, but it's just a single character, we use single quotes. Easy to remember, right? Single character, single quotes, string of text, double quotes, okay? So not all programming languages do that. Some programming languages do not really distinguish between single characters and strings. They just say, well, a string that has only one single character, yeah, we'll look at it as a single character. Now, in Java, we don't do that, okay? There's a difference of data type between single characters and a whole bunch of characters together that form a text. So this is how you would write down, this is a notation in Java for a character data type, a char data type, literal. So this is a literal value that has the value of character Q, okay? And you can also assign those literals to variable later on. So building block 1, building block 2 are covered here with that notation. So here we have a new data type. So the funny thing about this new data type is, if you notice, the name of the section for the slide is numerical data types. And then I just told you about a data type here that doesn't really look numerical. It's a character. So what gives? Am I mixing together things that do not belong together? Well, it's kind of weird, okay? It's kind of weird because the char data type in Java, and in actually many programming language, internally, the characters, like for example, single quote Q, single quote, right? Or single quote, uppercase A, single quote. Those characters internally, inside the variables key and A in those examples, they are stored as a very small positive int value. Okay, so that means that when we store the letter key here, so I already distinguished here between a string and a single character. So let's just go to the next remark. When I store like the letter Q here, I'm referring to something that looks like this. This is the ASCII table. Okay, this is actually a very old way to represent characters, but the modern way to represent character, which is Unicode, is actually backward compatible with the ASCII table. So I use the ASCII table just to express and to illustrate the concept of representing single characters by codes, by numbers. Okay, so if you are curious, check out the Wikipedia page for the ASCII table. Here are some other reference website. Okay, but we are just going to give like the basic explanation here. So what is this table about? Well, we have a column here which contains appear in red, which is going to represent single characters. So the first thing you're going to notice is that when I look at the first series of single characters, these are weird. Okay, escape, that's a character. There should be like chi-edge return, something like that. CR, there we go, chi-edge return. What else? New line, something like that. Line feed, there we go. So tab, escape. I mean, these are control characters. Okay, these are like special characters. They are not really character that you display. These are characters that represent, for example, the end of a line of text. Okay. So let's take a look at the second group of character here. So the character here are space, exclamation mark, double quote. Okay, so all of the symbols, operators, punctuation, stuff like that are here, followed by the digits, 0 to 9, followed by more punctuation and operators. The @ symbol is here, and then we go A, B, C, D, E, F, G, all the alphabet, the Latin alphabet, uppercase, more square braces, a @ symbol, underscore, etc., and then the lowercase alphabet, and then a few more of those parentheses, and a control character here that correspond to delete, moving the cursor back to the left, pretty much. So this table shows all of the characters that are part of the basic so-called ASCII table. And it tells us what is the code of the character. So it tells us what is the code of the character in decimal, hexadecimal, and octal. So we haven't talked yet about the number systems. So if you never heard of that, well, let's focus on decimal for now, okay? And then I'll introduce the hexadecimal base and the octal base. You'll be able to come back to decimal and it will make sense. So for each character, right, I am given the values, the code for that character, but you could look at it like an index for that character in the ASCII table, and I'm giving that that value in 3 different bases. So if I just pay attention to decimal for now, I can tell you, for example, that the uppercase A letter correspond to the ASCII code 65. That's one way to say it, okay? Meaning that when I assign to a char variable single quote uppercase A single quote, the char literal uppercase A, I actually store inside that variable a code which is 65. And 65 happens to be the index. Okay, like if you look, we start the table at 0, 1, 2, 3, 4, 5. So this is the index, this is a position in the table of the literal uppercase A. So when you store a single character in a char variable, that's what you store. Why is that important? Well, because sometimes that allows us to do some weird thing, okay? I'm going to take a quick example here. Let me bring up Jiggas. So we can treat those char variable a little bit like if they were numerical. So they're kind of a hybrid. They are at the same time a single character, and at the same time, because a single character is stored as a small value, a small int, I can sometimes do some arithmetic operation on them. So let's start by taking a look at what happens when I do system.out.println and I display the content of a variable of type char. So I defined a char variable here, initialize it with the character, single character, literal A. So I use single quotes to write it, and then I display it. All right, let's take a look at this first. So Control B, R, there we go. I display the character A. Well, yeah, I stored the character A in my variable. It's kind of expected that when I display the content of the variable, I get the character A as well. Okay, but what if I do something like that? So first, what if I do something equal B? Well, okay, I just assigned a new value. So let's take a look. All right, run it. Well, of course, if I display it, it's going to show something on the screen. If I don't, it's not going to show something on the screen. So let's try again. There we go, B. Okay, no, nothing really fantastic here. But what if I do this? Something equals, and I don't remember what it corresponds to, but I have this on my notes. 113. So this, what is the data type of that? This is an integer literal, okay? And in Java, every integer literal has a data type int. That's a default data type for a value like 113 that you write like that in your program. So this is a value of data type int. What kind of business do I have assigning it to a variable of data type char? Well, do you remember what I told you like a few slides ago, right? If I have an int value, I can fit it inside a double variable. Why? Because the double data type is larger than the int data type. So it's kind of like what's going on here. It's that notion of conversion that are allowed implicitly by Java. Okay, and we're going to talk much more about that when we do typecasting, okay, type conversion, data type conversion. But for now, we're just rolling with what Java allows us to do without any special syntax or without even thinking really about it. It's automatic. So if I try to assign a number like a small positive integer number like 113 to a variable of type char, Java is going to say, oh, I see what you're doing there. You know that a char is internally represented by a small index. So you are giving me the index for that character. So now if I try to display the variable something, it's still not going to display 113. It's just going to say, oh, you want to display the variable something? It's a variable of data type char. So let's take a look at what's stored inside of it. 113? All right, let me take 113 and I'm going to look up in the ASCII table. There we go. This is index 113 that corresponds to a lowercase q. So here we are. I display the lowercase q on the console. Okay. So that's pretty much the idea of char representation, and that's why they kind of found their way, in the section that describes pretty much numerical data type. In essence, they are numerical, and as soon as we learn to do typecasting, we are going to realize that we can actually do some arithmetic operation on something. For example, we can write things like, for example, there we go. Well, okay, let me start with the obvious, okay? I can write things like this. 113, instead of giving you 113, I can have an expression that's going to give me an int. So 113 plus 5, that would be still acceptable. But what about if I try to mix and match and I say things like, for example, let me assign here something equal b plus 2. Does that make sense, b plus 2? So here's the thing, B is a letter, a single character, right? But it's represented by a certain ASCII code. So when you say B plus 2, Java automatically understands that, oh, I see what you're doing. You want to add an int value to a single character, so I'm going to take the code for that single character, and I'm going to add this int value to it. So that's going to give me a letter that is 2 letters further down the list. And then you store that in a char variable. Okay, so that's going to be the index value that represents a letter. When you try to display that variable, it's going to show on the screen as a letter. So these are the rules that are implicitly enforced by Java in terms of converting values the easy way. And then, like I said, next lecture we're going to look into details on how we can actually force some conversion and what are the conversions that do not quite work, as simply as this. But right now, the main thing I want you to get out of this is that, yes, in many programming language, a single character is represented by a small integer value that corresponds conceptually to an index in a table like the ASCII table, or to take an example that's more modern, the Unicode table. What's the difference between ASCII table and Unicode table? ASCII table is old, and as you can tell, it had only very basic characters for just the Latin alphabet, pretty much. Unicode, the Unicode table is a lot bigger, and it actually contains entries for all the characters that you can use in languages such as Mandarin, Russian, and so on and so forth. Okay, so from the perspective of making your program more international, then definitely everybody wants to use Unicode nowadays. All right, another topic that we already mentioned, so just refresher. This one I really don't have much to add to it. We talked about constants, right? So I told you a variable is actually something that you can change, but if you put the keyword final in front of the declaration of a variable, well, once that variable is initialized, for example, here pi is initialized to 3, 14, 15, 9, well, it's locked down. So the final keyword allows you to turn what is, in essence, a declaration of a variable into a declaration of a variable. So the syntax is final, data type, identifier, equal sign, single equal, arithmetic expression, semicolon. Okay, well, arithmetic expression because we talk about arithmetic data types, okay? But if you add another data type, then the data type of the expression would be also different. We saw also that if you try to assign a new value, the compiler will intercept that and let you know that this is not a good idea. And we talked also about the fact that if you declare a final int answer variable, so when you declare a variable as being final, generally we refer to it as a constant, right? If you declare it but you do not initialize it, then the compiler will allow you to assign one value to it. So answer equal 42 doesn't trigger a compilation error. But if later on you try to change that value with another assignment, then you're going to get a compiler error. So the bottom line is when a variable is declared final, it can be assigned a value only one time, either when you initialize it, or later after the declaration, like 50 lines of code later, maybe. But once you have a value inside of it, that's it. It's locked down. And just while we are at it, okay, the convention, again, this is not enforced by the compiler, but it's enforced by your colleagues. The convention is when you declare a variable as final, you spell it all uppercase. Okay, we're going to have one slide on identifier syntax rules and stuff like that. Okay, well, actually, there we go. We have our identifier syntax rule here. So this is not about the uppercase names or stuff like that. This one is a little bit more technical, I would say, because the compiler enforces it. The idea here is that we have been using variable names like value, okay? Things that are words, English words, or maybe like several English words, one after the other. So we use the camel case notation, okay? But Java is a little bit more open than that. Java allows you to start the name of a variable with an underscore symbol or even with a dollar symbol. So sometimes you're going to find in programs weird looking variables, like for example, int underscore value equals 0, int dollar value equals 0. Well, that's legit. Okay, so the rules actually for naming a variable, for creating what is called an identifier for the variable, is to put only letters, digits, underscore, you can have 0, 1, 2, 3 underscore, as many as you want, and dollar sign, same thing. You can have no dollar sign anywhere in the name, or you can have 1 or 2 or 3 or 4, etc. And the other rule is that the identifier needs to start with a letter, which is what we have been doing until now. That was the easy, natural thing to do, right? But you can also start with an underscore and a dollar. So you can use almost any of those characters that are allowed here in the name, except you cannot start with a digit. So you can call something, for example, value 3, okay, but you cannot call something 5 value as a name in one word. So these are like very, what to say, these are rules that you need to hear about. for this course, for the next course, I would say, even the one after that, don't worry too much about that. Try to take names for your variables that are clear, that are meaningful, but don't try necessarily to play with the more exotic syntaxes that are allowed in Java. That's really not bringing any readability to your program. Another thing that I mentioned before, and I'm going to reiterate here since we're going over those syntactical rules, when you pick up a name for your variable, you have to make sure this is not one of the Java reserved keywords. For example, int, trying to call your variable int, so you would declare it by writing int equals 0, it's not going to work. Trying to call your variable static or void or class or public, not going to work. So there are about, I think, 30 keywords or so in the Java language that are off limit. True, false, null. This is a new one that we have not played with yet, okay? But also keywords that appear in syntax coloring in Jiggas, pretty much off limit. You cannot use them as the name of one of your variable. You cannot use them as an identifier for one of your variable. Naming conventions. So the previous slide was syntax, right? This is stuff that makes the compiler yell at you if you do not respect the syntax. And this is the convention among human programmers. So we talked about the camel case notation. Everything that is a method name or a variable name is going to start first with a lowercase and then use the camel case notation, which means capitalize every word that follow, okay? If you have a class name, then same rule about the camel case, but you start with an uppercase letter. And if you have constant, well, all uppercase. And if your constant name is made of 2 words, then separate them with an underscore. And that's it. We already covered those. Now, this is new. This is new. We are going to talk about different numerical data types. So far, we talked about int, here it is, and double. So when you have an int variable in Java, that means that you use 32 bits, 32 0 and 1s in memory to store the value. And the value can be positive or negative, so we say it's 32-bit signed. And it gives you a range of possible value. So for an int variable, you can store anything from minus 2 to the power 31 to 2 to the power 31 minus 1. And here you have the exact numbers if you are curious. For a double, that's a little different. First, we take twice the amount of memory, so 64-bit. And the way that we actually use 64 bits to represent a floating point number is actually a very specific format that has been standardized by the IEEE called IEEE 754. So this is actually the way that we must interpret the zeros and ones, the 64 bits of data, to be able to decode them into a floating point number. Without going into detail, that means that we are going to use some of those bits to store the mantis of the number and some of the bits to store the exponent. Like when you write and read a number in scientific notation, for example, minus 4.9 exponent minus 324, right? This is your exponent. This is actually your mantis, right? So there is a very you can look it up on Wikipedia. It's interesting actually if you are interested by low level that kind of low level details, okay? But that we are going to talk more about that encoding from a very pragmatic perspective, which is that a lot of arithmetic on floating point number is not as reliable as you would think it is, when you think about using a computer to do some calculations. So we'll come back on that topic. But for now, we're just, looking at the zoo of different available data type, numerical data type. And I'm just letting you know that, the int is 32 bits, the double is twice the amount of memory. The range for a double is actually from minus 1.7, blah, 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 exponent plus 308. So we can store much larger numbers, right? To minus 4.9 exponent minus 324. So it's something very, very, very small there, okay? So that's a negative range. And then the positive range, again, we can go from very low exponent to very high exponent, okay? So that kind of tells you when to use one or the other. That's pretty easy. Besides the fact that here we don't have a decimal part and here we do, the range of value also help you decide. So what if you want to store an integer, but you know your integer is not going to go anywhere near those values, okay? Should we use 32 bits of memory to store something that is going to be very small? Uh, well, if you are like in the mood to bloat your application, you can. Okay, this is why I just introduced the int data type at the beginning, because you're not going to break anything. You're just wasting a little bit of memory. And for most desktop application, and definitely for all of the code we write in this class and the next and the one after it, it really does not matter much. Okay, so I could say, for example, instead of declaring my variable of data type int, I could declare it with the data type short. And the short data type uses half the memory compared to an int, 16-bit instead of 32, and allows me to store roughly from minus 32,000 to plus 32,000. So if I know my values are going to be in that range, why use an int? I could use a short, make better usage of my memory. And if I know that I need even less, like 8-bit are enough, so a value between minus 128 and 127, well, there is another data type in Java, the byte, that's going to allow me to store such values. So all of these are integers, okay? These are integers, integer data types. The int is actually the standard in Java, like the default. Short when you want to save memory, byte when you want to save more memory. But what if, of course, my value is like I have an application and I know my values is going to get outside this range? Then I have the long data type, which is the biggest of the integer data type that allows me to store between minus 2 power 63 to 2 power 63 minus 1 using 64 bits of memory. So I have like 4 different integer data type, and I pick the one that I think is suitable for a variable based on what I expect the range of the values I want to store in that variable to be. Okay, and in that we could go always long, very be wasteful, so certainly, but we could always go long to make sure that we accommodate the largest number that we can. But the default in Java is actually to go with the int data type. So when you write a value like 123 in your program, so when you use an integer literal, the integer literal in Java by default are of int data type. The same way that the floating point number literals in Java are double. But there are not that many floating point data types. There are only 2 of them. The double that we have been using, and that is a default in Java, it's actually the largest. It's called double, by the way, because because it provides double the precision of the other floating point data type, which happens to be called float for floating point number. Okay, so bottom line of the story: a float variable, a variable that you declare with the data type float, occupies 32 bits in memory. It gives you those ranges, and if that's not enough, then the double data type is going to use twice as much memory and give you much bigger ranges. Again, the default for all integer literals is int. The default for all floating point literal in Java is double. So now that we have more than just int and double, let's talk about the scanner. Because like I told you, the scanner, it kind of contains all of the method that you use to do reading of data from the keyboard, in our case. But later in COP2513, we're going to also use scanners to read from files, for example, or read from the network, like read from a web server, a web page contents. So, so far we have been playing with the method nextInt. So import your scanner, declare your scanner variable. Here I'm going to call it input. And then you can do things such as input.nextInt. Well, nextInt is not the only method that you can use in the scanner that you created here. Okay, so you could use input.nextByte, nextShort, nextInt, nextLong, nextFloat, nextDouble. So for all of the numerical data types that we discussed, there is a next followed by the name of the data type. Okay, there is a next byte, next short, next int method that's going to read whatever is typed on the keyboard and return to you a value of that exact data type. So if you read a value with next int, what kind of variable can you store it inside? Well, you can store it inside of an int variable, of course. If you read a value with next int, you can also store it inside a double variable, right? Because the double variable has a bigger range than int, or even a float variable. So all of the remarks that we have been saying until now about assigning values, of course, they're going to apply also when you get a value from calling a method, like, for example, one of the scanner method. So when we talk about I/O, input/output, so this would be the input part, okay, how to get numbers from the user into our program. What about the output? So this, as an output for us, we do some very basic stuff in COP2512, 2513. We do console application. So when we output to the console, text format, right? So let's take a look here. The only thing that I need to add here, we already talked about the difference between print and println. You've seen me, especially at the beginning of module 1 and 2, you've seen me use like 4 or 5 print or println statement one after the other. And then around module 2 or 3, I don't remember exactly, I introduced the syntax. And that syntax is actually what everybody who wants to remain sane is going to use. So instead of repeating system.add_println this text, then system.add_println the value of that variable, then system.add_println and this text, and then and so on and so forth, what you do is between the parentheses of your system.add_println, you actually say, I'm going to display a message that is a result of concatenating this text with the value of this variable, then concatenating it with text that has a space, some text, a space, and then the value of another variable. So the plus sign here doesn't mean addition, it means concatenation of strings. So you can do a string plus another string, it just puts them head to toe, and one after the other, that's called concatenation, right? So that allows us to use one single println, and as I think sooner I said, here we could use 1, 2, 3, 4 println. So really what we would use is a print, so that we display the area after, a print, and then finally a println. Here, just one println is going to pretty much build up that message, okay, and then display it. The one thing that you have to watch out for is we have used actually print and println to also display the result of expressions, like numerical expression, right, arithmetic expression. Like if I do println 2 plus 3, I'm getting 5. That nothing surprising there. But now we have a different kind of expression here. These are not arithmetic expressions. The plus doesn't mean addition. It means concatenation with a string. And when you try to concatenate a string with another string, it gives you a string. If you try to concatenate a string with a value, like a numerical value, then Java is going to convert that numerical value into text, into a string, and stitch the two strings together, right? So if I do things like, for example, 2 plus a space plus 3, what do you think the output is going to be on the screen? Take a second and try to guess. It's going to be 2, followed by a space, followed by 3. So what happened exactly under the hood? So Java realized that you were trying to add 2, which is what? It's an integer literal. What is the data type of an integer literal in Java? Int. And so we are trying to add a value here of data type int2. What is this? This is a string literal. What is the data type of a string literal in Java? Well, that's string. It's called string, okay? So I'm trying to add an int to a string. And Java realizes that, oh, we are not talking about the addition, the numerical addition. What you want to do is you want to convert this value into a string, some text, and then stitch it with some more text, like a space character. And then again, same reasoning here. This is an int literal, so I'm going to convert it to a string, and I'm going to stitch that string at the end. So really what we are displaying here is a string that has 3 characters. The result of this expression is a string that has 3 characters, the character 2, the character space, the character 3. And that's indeed what ends up coming on the screen here. So if I do things like that, for example, if instead of having a space, I have an empty string, well, that doesn't change anything, except that I'm going to have 2 followed by 3. But that conversion, because I'm adding 2 to a string, even though it's empty, and then I'm adding the result of that, which is a string to 3, that those concatenation are going to make me display not the result of 2 plus 3, 5. No, I'm going to display 2 followed by 3. So this is where all the details go, and the devil is in the details, right? So now what we are learning is that this syntax here that allows us to save a little on the number of print and println that we have in our programs. You really need to understand how it works, especially with respect to its relation to the plus operator that is also used, to add strings to one another, to concatenate strings. So now that we have unleashed that syntax, and that's the reason for which I didn't introduce it earlier in the class, now we need to talk about, the idea of type conversion, that 2 becomes double quote 2 double quote, the string that contains the digit 2. And then we concatenate it to a string that contains a space, so that gives us a string that contains 2 followed by a space, and so on and so forth, right? So a little bit more complexity here, technical complexity, but the principles are still the same, right? We're not talking about the programming thought process here anymore. We're talking about how Java works and how Java notation can become a little bit more complex. What about this one? Empty string, plus 2, plus 3, empty string. So there are two ways that could go, right? That plus here in the middle could mean I do 2 plus 3, 5, and then I do 5 plus an empty string, so that's giving me a string that contains 5, and then a string that contains 5 plus an empty string, that gives me again a string that contains 5. Well, let's take a look. Nope, that's going to display 2 followed by 3. So the way that it's going to be evaluated, and we're going to talk more about that when we start talking about operator precedence, okay? So every time you have an expression, you have a bunch of operators and you have a bunch of operands, right? And then we need to know which order Java uses to apply those operators to the operands. So in this case, we go left to right. So the first operation is a plus. Is it the numerical plus or is it the string concatenation? Well, let's take a look. The operand to the left is a string. Forget it. This is string concatenation. If one of my two operand is not a number, it's a string, then I'm going to default to, I'm going to do only string concatenation. So how do I concatenate an empty string to a number? I upgrade that number to being the string that contains double quote 2 double quote. And then now I concatenate those two strings. I get a new string. Here we go, a string plus a number, upgrade the number to a string, I get a new string, and then a string plus a string, well, that's it, I just concatenate the two strings, okay? So there are some little subtlety. For example, in this case, the first thing that generally students encounter is, but what if I want to display, for example, 2 plus 3 here, 5, and I want to work it up in the middle of a message, for example, that I'm crafting in my expression here. Or what if I want the name of a variable multiplied by 2 or something like that? You can do that, but what you have to do is you have to parenthesize it, because now you're telling Java, here's an expression. I'm using parentheses to tell you what I want you to evaluate first. The first thing I want you to evaluate is 2 plus 3. So what is this plus? Is it going to be the numerical plus or the string concatenation plus? Let's take a look at the operands. 2 and 3, these are numbers. These are literal, integer literal of data type int. So 2 plus 3 equals 5, which is also of data type int. And then I find myself resolving this addition, this one. But these are not numerical addition. These are going to be concatenation, okay? Take your time, review this slide. This is very important stuff. It's setting pretty much the stage for the topics that we're going to discuss in the next lecture, which are going to be data type conversion, okay? Like what I'm showing you right now is pretty much all of the conversion that happen, whether you know that that Java is doing data type conversion or not. Okay, and that's kind of dangerous if you think about it, because that means that you can use those things, and if you don't understand them like thoroughly, right, then you're going to misuse them sooner or later. So that's what we are dealing with in Module 4. We are dealing with additional complexity in the syntax. We are dealing with understanding how Java really does things under the hood, a little bit deeper than what we have been doing in Module 1, 2, and 3, so that you actually are capable to write code in Java in different ways, but still with a very solid understanding of what your code means. Okay, So that goes into tracing and all those skills that we discussed before, tracing, implementing, stuff like that. So I've been talking a lot about number literals, right? I introduced that term literal value, I think during probably our second lecture, something like that, module 0. So I told you a literal is a value, like for example 123, or here we go, like 34, 5.0. What is that? That's like 1 million, you know. So all of those values, they are literally typed into the program. That's why we call them literal. Hello word between double quote, that's a string literal. That's some text that is typed directly in the program. But right now we're talking more about the numerical things, right? So you could say that a literal is a value that is not computed as a result of an expression. It's not returned by a method that you called, and it's not entered into the program by the user via a scanner, which, when you use a scanner like s.nextInt, it's pretty much calling a method, okay? But I'm trying to kind of like look at all the different possibilities. So these would be examples. I initialize those variables with values that I typed directly inside my code. I mentioned also that when you assign a literal to a variable, that when you use a literal to initialize a variable, or when you assign a literal to a variable later to change its value, you need to watch out for data types, okay? A variable has a data type, int I. And then every literal value that you are going to type in your programs are going to also have data type. What is the rule that we already introduced? If it's an integer, the data type is int. Assign an int to an int, we're okay. If it's an integer, the data type is an int. Assign an int to a long. Long is bigger than int, we're okay. What about 5.0? If it's a floating point, the data type is double. Assign a double to a double, we're okay. What if d was a float variable? It's not going to work. 5.0, even though it's a small floating point number and it would totally fit in a variable of data type float, because we say the variable as a data type float, and because Java keeps track of 5.0 as also a data type, and by default is going to be double, then Java is going to tell you you cannot shove a double inside a float variable. Okay? So we are going to get into a lot of those computation error. The rule is always figure out the data type of the value, figure out the data type of the variable. If they match, you don't have any problem. If they don't match, always make sure that you assign something that has a smaller data type to a larger data type. Otherwise, it doesn't fit pretty much. Okay. So let's talk a little bit more about integer literal, and there you go. I anticipated what I was going to say, so that's good. That means that the progression of the lecture makes sense, at least to me. So we want to be able to assign as long as it fits. So let's take a look at this code example. Byte b equals 1000. So byte is the smallest of the integer data type. It allows you to store only values between minus 128 and plus 127, if I remember that correctly. So if I was trying to write byte b equal 1000, the data type of 1000, because it's an integer literal, by default is int. Try to assign an int to a byte. The int data type is bigger than byte. So regardless of the value, forget it, that's not going to be accepted. And this is a kind of error message that you get. Get used to those, okay? Incompatible types, possible lossy conversion from int to byte. That means lossy conversion means you are trying to fit a larger data type into a smaller one, int into a byte. So every time it's going to warn you that if I try to fit, this potentially big number, I don't know how big your number is, but since it's an int, it can be this big. So if I try to fit a potentially large number into a small bucket, it's not going to work. We're going to lose some data, okay? So I already told you what is the default literal. So now the question is, if all the integer literals are int, of data type int, and all the floating point literals have data type double, it kind of like limits what we can do, right? How do I write a number and I want to say, for example, this number is an integer, but it's not a regular int. For example, it's a long integer. So meant to go in the variable of data type long. Well, there are tricks. So again, this is syntax, syntactical knowledge about Java. In Java, if you put the letter L, whether it is uppercase or lowercase, if you put the letter L at the end of an integer literal, then what you just said is, I want to change the data type of that integer literal. So 1000 means 1000 as an int. But if I write 1000, 1000, and an uppercase L right at the end of it, then that integer literal is going to be considered to be a long instead of an int, as far as data type goes. Okay? So we have ways to write literals and influence how Java looks at them. We can do that also with floating point literals. For example, 100.2f. So if I just write 100.2, it's a floating point literal. What is the default data type in Java for all floating point literal? Double. So if I write just 100.2, that value has the data type of double. So if I was trying to assign it to a float variable, it would tell me your float variable is too small. Even though the value is small, it says the data type doesn't fit. So if I want 100.2 to be considered as data type float, I can add at the end of it, no space, just like before, I can add the letter F for float, uppercase or lowercase. If I ever have to insist, it's a default in Java, but if I wanted to explicitly mark this 100.2 floating point literal as being of data type double, I could append a lowercase or uppercase d at the end of it. Okay. Last thing we're going to talk about regarding notation for literal, the scientific notation. So it's the same as the scientific notation that you have been studying in K-12 environment. Okay. So if I want to write, for example, 1.23456, and I want to say it's this number times 10 to the power 2, right? So times 100, so I'm going to switch the decimal 2 places. It's going to be 123.456, right? The scientific notation is 1.23456. E, letter E can be uppercase or lowercase, and then without spaces anywhere, plus or minus, depending on if you want an exponent that is positive or negative, and the value of your exponent. Okay? So this is the kind of stuff that you are used to. For example, here we go, 1.23456 exponent plus 2, that gives you this, minus 2, that will give you this. We're just switching, moving the decimal dot 1 or 2 places to the right or the left. Okay? So Java accepts floating point numbers that can be written like that. So this here, for example, that's a floating point literal in Java. What's the data type of a floating point literal in Java? Double. So even though I'm using the scientific notation to represent my number, okay, if I write it like this, it's a floating point literal, by default, double data type. If I write it like this, it's still a floating point number literal, so it's still a double data type. What if I wanted this to be considered a float? I would add a F at the end, uppercase or lowercase, okay? So as far as integers goes, generally students do not have problem understanding, well, if I want to store, for example, values between 5 and 15, I can use a byte. It's big enough. If I want bigger than that, then go to int, go to long, and so on and so forth. For floating point number, it's not that complicated. It's just a little different. Okay. For floating point number, it's not only about how big the number is, because a floating point number is made of an exponent and a mantis, right? The more bits you have to store it, the bigger can the exponent be, but so can be the mantis. So we are going to talk here about significant digits. For example, if I try to display 1.0 divided by 3.0, 3.0 is a floating point literal. What's the data type of a floating point literal in Java? Double. So same thing for 1.0. So this is a double divided by a double. Okay? So the result is going to be 0.3333 with 16 digits here as significant digits. That's the representation of 1 divided by 3 as a double. And if I switch to float, so I mark this as a float, I mark this as a float, I do a division. So here's how operators work, right? And we're going to, again, revisit that when we do typecasting, but when you try to divide a value by another, I look at the data type of the operand, okay? And if one of the operand is a double and the other is a float, I switch the small one to the big data type. So I switch the float to double. But if both of them are double, the result will be double. If both of them are float, the result will be float. So here I still do 1 divided by 3, right? But because 1 and 3 are both of float data type, then the result will be a float data type as well. And you can tell that there is definitely less significant digits for a float than a double. So that's about accuracy of your computation, okay? We're not done talking about everything that can go wrong with floating point number, but the most obvious thing that can go wrong with floating point number is if you want a lot of significant digits and you use a float, well, you might actually get into trouble faster than if you use a double data type, okay? So that makes the decision, relatively simple still. As far as COP2512, 2513 are concerned, we are going to do the vast majority of our floating point arithmetic using the double data type. It's because there are not many reasons to use a float just to save a little bit of memory in our case. All right? All right, with this being said, we are at the end of the slide deck for this first lecture of Module 4. Thank you for your attention. And if you have any question, please feel free to post on Piazza. I will be glad, I or the TAs will be glad to help you out. All right, thank you again.